Mr. Anup Wadhwa. He is Director at Automation Industry Association. He is an alumnus of IIT Delhi, from where he completed his bachelor degree in technology in electrical and electronics in 1975. His passion for digital electronics started in college that later took him to an exciting career in field of industrial automation. Today, Mr. Anup will talk about building capacity for smart manufacturing. Let's welcome Mr. Anup.
So good afternoon to all. I would like to still, take a step back because today's conversation is about transition to smart factories and adoption of smart factories by India. I'd like to take a step back and say that who are the people actually building these smart factories and how are they actually built? Now, here is a little bit of extract from a report by UNIDO of 2018. But knowing that the Europeans started the journey almost 10 years before us, the learnings are very valid even today in 2021. So the first admission by UNIDO is that no single country at that point was able to fully transform large parts of its manufacturing base into Industry 4.0. Now that is quite concerning. It definitely shows that there is a high degree of complexity and understanding, and that needs to be recognized, particularly by SMEs, before they really can make a claim that they are transitioning to smart factories. The other thing is about trial and error being at the source of building your foundation for learning and implementation. Now, if we take all these three pointers, it definitely means that entry into the cyber physical world or the promised future or the promised smart factory will happen only if we can cross certain entry barriers. Now, I'm presenting a possible list of entry barriers. I'm not claiming that these are the only entry barriers or that every company will have to confront all of them. But just to give a sense of what some of these are, let me spell it out for you. The first is poor instrumentation. Let me say this with a caveat. We are not talking about Tata Steel, or we are not talking about Volkswagen or Reliance refinery. We are talking about the small and medium enterprises which constitute a bulk of our manufacturing capacity and employment of people. So poor instrumentation continues to be one entry barrier. The next hurdle I would say is the absence of machine-to-machine communication. Now, in the automation world, it's fairly simple to connect multiple machines, but the historic evolution of plants has been such that machines have been bought with either no communication port, or even if there was a port, the communication protocol was not matching, and therefore companies were running these machines with different kinds of integration, particularly I/O integration and less M2M communication. The third, which is very, very relevant, is the fragmented data approach and the poor real-time analytics. We go around and see many shop floors, and everybody says, well, they do have data, they do have job cards, but you'll be surprised that many of these job cards are filled post the event. There's hardly any real-time data coming and getting embedded into the management information systems. Now let's look a little bit about the human aspect. We have role ambiguities along multiple disciplines, which means you could have everything going well when the plant is working. But if something is not working, we are looking at each other and saying whose job it is. That's typical of many enterprises. The other one, which points to the inadequate robotized utilization, whether industrial robots or cobots, is also going to be a barrier, because you cannot achieve end-to-end, productivity having islands of automation. There are many companies which have fairly automated CNC machines, but 95% of them will have manual loading and manual unloading. And therefore, there is quite a gap when it comes to achieving global benchmarks in productivity. And another entry barrier is when you have process variability, who's going to take the buck, who's going to account for it. So these are some of the difficulties in moving up the barrier. And this was realized by the government way back in 2017, when we had a discussion about setting up certain common facilities for India. And one of the realizations was that awareness about technology is not going to be enough. As I mentioned, there will have to be lots of trial and error, and we can't put the onus of this experiment on the end users, particularly SMEs who don't have that cash surplus. So the government took the responsibility of creating common infrastructure with lots of technology components, hardware, software, networks, simulation, robots, and said, do your trial and error here at these common facilities, and whatever works for you, go back and adopt. So that was the realization. And another realization by the government was, and if you can see this slide, I don't know if you can zoom it, but if you see the quadrant which says India is placed in the legacy quadrant. Now let me explain a little bit about these quadrants. So on the left side, you have the future readiness, and on the right side, you have the scale of operation. So if you see, let me move my cursor. So moving from low future ready to high future ready, India is somewhere in the middle. And if you look at nascent and legacy also, a lot of our manufacturing are legacy machines, which means that you can't do much changes there. You can't set up a brand new factory like the Ola factory, and you'll have to make do with machines and people as they are. So that's the available asset of these enterprises. And taking charge of this challenge, the government also put out a roadmap. And here, instead of calling it only smart manufacturing, we introduced another connotation. We called it the Samarth Udyog. Now, Samarth actually translates into smart, advanced manufacturing and rapid transformation hub. Recognizing that transformation is not just about buying and deploying technology, it's about people, it's about the process, the culture and technology, and also the availability of talent that we as a nation now need to think what is the fastest way we can move in this journey to the digital make in India. Now, digital is the key word. If you digitally want to make anything in India, the cycle actually starts from the design. Whether it is the product design, whether it is the plant design, everything has to start emerging as a digital thread. Otherwise, you will not be able to carry this further. And the other punchline to this is the deployment of technology should result in people empowerment. That's when they're really going to make the best use of it. That's when they're going to demand it. I don't know what's the background of the listeners, but I presume most of you already have investments in current manufacturing lines. You also perhaps have a lot of people already deployed. So the dilemma for most companies today is that when they want to move up the talent pool, do they invest in reskilling and making their technicians smart, or they should leapfrog and they should hire a brand new set of people called data scientists? Now here there is definitely a push and pull happening. The automation companies are quite comfortable dealing with the technicians who handle the machines, and therefore they already have programs to upgrade these technicians through various kind of training programs. IT companies are more comfortable in the genre of people they call the data analysts or data scientists, and therefore companies will have to take a call as to where they invest their buck in the training of people. From my own experience, of course, the caveat is I do come from an automation background, but in our facility, which we have in the Samarth network, we also deploy high-end software, simulation tools, digital tools. And what we have found is that about 70 to 80% of the comfort customers come purely if they are able to get existing people up the curve. Now, whether it is prototyping, whether it is consulting, whether it is site integration, a lot of these call for domain knowledge, and domain knowledge scores at the end of the day versus just the ability to write codes of data. As already said by my colleagues, it's becoming very easy to program and very easy to switch from one kind of database system to another database system. So my case would definitely be consider investing in the technicians. As I come to the end, I also want to talk about a possible roadmap in this digitalization journey, because I find a lot of customers are approached by many vendors, and a lot of the solutions seem very logical, but they don't know where to start and which way to go. I just like to offer some off-the-cuff advice, and I think it will stand good in majority of the cases. If you break down your journey basically into three buckets, first is your current assessment, the operational, technical, financial, and skill assessment on the ground. Where are your process capabilities? What is your safety? What is your energy? How do you do tracking, tracing? What are your training needs? That has to be the starting point. And then you go about, as I said, crossing some of those entry barriers, whether it is instrumentation, M2M communication, introducing digitalization, etc. And ultimately, then you go for implementation of best practices and full-scale deployment. Now, if we want to move in bucket one and perhaps also get a feel of bucket two, my recommendation is that consider taking 2-3 critical machines and do OEE pilots. Now, what do I mean by OEE pilots? OEE is a very standard industrial engineering measure which tells you how good your asset is to contribute to your profit. If your machine availability is high, your throughput is high, your quality is first class, you obviously are going to make profit every time this machine runs. On the other hand, if there are losses and these losses are either not captured, or if captured, you don't have a quick ability to turn around and cover for these losses, then your profit is getting eroded day by day, hour by hour. So if you get on this journey of converting your machines, the ones which are regular in production, put in a good OE system, you will, by force, you'll be looking at essential instrumentation, you'll be looking at essential data connectivity, you'll be looking at essential root causes, and therefore you will start marrying your physical world to the cyber world. Now, is this journey worth it? I think if we look at the spread of Indian manufacturing companies and their capability to serve the global market, there is a huge gap. These numbers are up for debate. Many of you can challenge it, but definitely the trends are there for all of us to see as a nation. If we do not get onto this journey of going for high productivity and consistency and reduce the job rework, and we reduce the manufacturing costs, we reduce the inventory holding, we reduce the energy wastage, we bring down the breakdowns, we have preventive maintenance, we have safety environment, and we have great quality and price competitiveness, and we are also conforming to regulatory compliances. These are all the ingredients for us to hold our head high if we have to compete in the manufacturing domain, if we have to be the product suppliers to the global market. And therefore, I would like to rest my case here. We do need Samarth Udyog, but Samarth Udyog is possible only by Samarth Log. And the way to do it, as I said, is to jump in, take a few case studies, and enjoy your journey. Thank you for listening.